Hello everyone. In the previous video we have learnt about the definition of matrix, order of matrix, representation of matrix and its elements and the construction of matrices. Now in this video we will learn about different types of matrices. The first type comes as rectangular matrix. As we know about a plane figure rectangle, in the rectangle we find that the length and the breadth of this are different. The same way here also in the rectangular matrix we find that the number of rows and number of columns are not equal, they are different. Then we call it a rectangular matrix. So we say if number of rows in a matrix is not equal to the number of columns, then we say it is a rectangular matrix. We represent the number of rows by m and number of columns by n. So we can also say here that if m is not equal to n, then it is a rectangular matrix. For example, suppose we have a matrix A. The elements in this are 1, 2, 4, 5, 3, 2, 8, 1, 4, 1, 6, 7. We are finding here the number of rows is 3, number of columns is 4. It means the order of this is 3 into 4. M is here 3 and N is 4, so it is a rectangular matrix. In rectangular matrix also we divide them into two different categories. The one is known as horizontal matrix. What is that? If we find in a matrix M is less than N, means number of rows is less than number of columns, then we call it a horizontal matrix. For example, we have a matrix P, the elements in this are X, Y, Z, P, Q, R. Here we find the number of rows is 2, number of columns is 3. Order is 2 into 3. It means here we find M is 2, N is 3. M is less than N, so it is a horizontal matrix. The second, here we have vertical matrix. Vertical matrix means if M is greater than N. It means if number of rows is more than the number of columns, then it becomes a vertical matrix. For example, we take some matrix X. The elements in that are 2, 3, 5, 4, 6, 1, 2, 8, 4, 1, 5, 3. We find here that number of rows is 4, number of columns is 3. Here the order we are finding is 4 into 3. M is 4, N is 3, it means M is greater than N, so it is a vertical matrix. The second type here is square matrix. As we know in the plane figures, a square has all the sides equal. Same way here also, a square matrix has number of rows and number of columns both equal. So we say if number of rows in a matrix is equal to the number of columns, then it is a square matrix. It means M is equal to N. For example, suppose we have a matrix A in which the elements are A, B, C, D. Here we find number of rows is 2 and number of columns is also 2. It means this is a matrix of order 2 into 2. So this is a square matrix. Another example, we may have a matrix B in which the elements are 2, 3, 5, 4, 1, 6, 7, 8, 9. Here we find number of rows is 3 and number of columns is also 3. It means this is a square matrix of order 3 into 3. The third type we have a row matrix. As the name itself tells, only row. It means it contains only one row. Number of columns may be any. So we can say that if there is only one row in a matrix, then it is a row matrix. For example, suppose we have a matrix and the elements in this are 4, 5, 7. This is of order 1 into 3. If we write another one, suppose we write P, in that we find the elements are A, B, C, D, etc. The order is 1 into n, suppose there are n elements. So we can also say a matrix of order 1 into n is a row matrix. Here we find the number of row is only 1, whereas number of columns is more than 1. So we can say this is also a horizontal matrix. The fourth type is column matrix. The name itself tells that this contains only one column. So we can say a matrix which contains only one column is a column matrix. For example, suppose we have a matrix X and the elements in this are 2, 5, 1. We find here number of rows is 3, column is 1. So order of this is 3 into 1. We can take one more example, that is Y, and the elements in this we are finding 2, 3, 5 and dot dot dot. There are suppose n elements. It means we find there are n rows and one column. So order of this is n into 1. Based on this we can also say that a matrix of order n into 1 is a column matrix. And as per the definition of vertical matrix, do you find that this is also a vertical matrix? Yes, because the number of rows is greater than the number of columns. Next, fifth type we have is a zero matrix, or we call it a null matrix. Here also we can see 0. 0 means every element of this matrix is 0. Order does not make any difference. So we say a matrix in which every element is 0 is a zero matrix or null matrix. We represent a zero matrix by 0 or O only. So we can say it is represented by O. Suppose there is one matrix O and we find here 0, 0, 0, 0, 0, 0. Every element is 0. So it is a null matrix or zero matrix of order 2 into 3. May have another one also. Suppose it is 0, 0, 0, 0, 0, 0, 0, 0, 0. This order is 3 into 3. So whatever the order of the matrix may be, but if every element is 0, we call it a zero matrix or null matrix. Before going to the next type, we have to learn what is the diagonal of a matrix. Diagonal is possible only in a square matrix. So we say let A, that is A, B, C, D, E, F, G, H, J be a square matrix. Then starting from this first element A, this particular one is known as its principal diagonal or main diagonal. It means what we can say about the diagonal. So we can say the elements AII, that is A11, A22, A33, etc. form the principal or the main diagonal of a matrix. So starting with the first element, the diagonal which is formed is known as the main diagonal. Sometimes we also call the second diagonal is also there. This is one of the diagonal. But since it is not the main diagonal, we call it the off diagonal. Based on the diagonal, we have the sixth type, that is the diagonal matrix. Suppose we have a matrix A and the elements in this are A, B, C, 0, 0, 0, 0, 0, 0. We find this is of order 3 into 3. The diagonal elements are non-zero. All other elements are 0. Then it is known as a diagonal matrix. We can also represent it as diagonal A, B, C. Only the diagonal elements. See here, diagonal elements are 3. So we can say this is a diagonal matrix of order 3 into 3. We can also write this another way. Suppose we are given a matrix B and it is given as diagonal 1, 5. There are only 2 elements in the diagonal. So we say it is of order 2 into 2. Suppose we want to show it in the expanded form, then this can be written as 1, 5, 0, 0 of order 2 into 2. So how we can define a diagonal matrix? We can define it a square matrix in which the elements Aij, where I is not equal to j, are 0 each, is a diagonal matrix. Next type is a scalar matrix. A scalar matrix is a square matrix in which all diagonal elements are equal and all Aij is equal to 0 for I is not equal to j. For example, we take a matrix A, that is suppose A 0 0 0 0 0 0. This is of order 3 into 3. We are finding the diagonal elements are all equal, that is A, and all other elements are 0. And if these are the diagonal elements, then we can call it a diagonal matrix also. It means we can also define it as a diagonal matrix in which all diagonal elements are equal. Next type is called unit matrix, or we also call it as identity matrix. Actually, it is a multiplicative identity that we will be learning in the next video when we learn about the operations. So what is that unit matrix? This is also a scalar matrix. But in this we find that every diagonal element is 1. 0, 0, all other elements are 0 each. This is of order 3 into 3. Generally we call it as I3, identity matrix of order 3 into 3. If we write another one of order 2 into 2, I2, that will be 1, 0, 0, 1. This is of order 2 into 2. And I2, I3 and all, which identity matrix is to be applied in any of the problem, that is depending on the problem which we have. So how can we define the identity or unit matrix? We can call it is a diagonal matrix in which every diagonal element is 1. We can also say that this is a scalar matrix in which each diagonal element is 1. And we can also call it as a square matrix in which each diagonal element is 1 and all other elements are 0 each. In the easiest language we can say a scalar matrix in which all AII are 1, or we can say all diagonal elements are 1 each. Scalar means automatically it says that all other elements are 0. The next type of matrices are triangular matrices. They are of two types. Number one, upper triangular matrix. What is that? We say a square matrix in which all Aij are 0 when I is greater than j. For example, we understand it by the example, we have a matrix A in which we are finding the elements as 2, 3, 4, 1, 5, 6, 0, 0, 0. What we find here? A21 is 0, A31 is 0, A32 is 0 in the matrix of order 3 into 3. Then why we call it upper triangular matrix? What we find here with the diagonal, if we see the upper part of it, all these elements are forming a triangle. You can see here. The lower part of this is having elements 0 each, and that's the reason we call it upper triangular matrix. The next in this second one we have is a lower triangular matrix. Opposite to this, we can say a square matrix in which all Aij is 0 for I is less than j. Here also we take one of the example. Suppose the matrix is B and we find this as A, B, C, D, E, F, and these are all 0 each. This is of order 3 into 3. We can see here A12 is same as A13 is same as A23. These all elements are 0 each. And the reason for calling it lower triangular matrix is also similar to that. That is, here we are finding with the diagonal, here we see the lower elements are forming a triangle. That's why we call it lower triangular matrix, and all the elements above this diagonal are 0 each. The next we learn about the comparable matrices. What are comparable matrices? Any two matrices are comparable if the number of rows and number of columns in both are same. or we can say the order of both is same. So we can say two matrices are comparable if their order is same. It means we can say A and B are comparable matrices if order of A is equal to order of B. For example, suppose we have a matrix A. The elements in this are 1, 2, 5, 6, 7, 4. The order of this is 3 into 2 because there are 3 rows and 2 columns. If we have another matrix B, that is A, B, C, D, E, F. Here also we find there are 3 rows and 2 columns. The order is 3 into 2. Elements may be different, but the order should be same. Then we say that they are comparable matrices. The next we have equal matrices. What are known as equal matrices? See, comparable matrices may be equal if the elements also are contained same in both. So we can say that two matrices A and B are equal if number 1, order of A is equal to order of B. It means they should be comparable. And number 2, Aij is equal to Bij. It means their corresponding components are to be same. For example, we have two matrices A as P, Q, R, S. The order of this is 2 into 2. Another is B. In this also we find the elements are P, Q, R, S. The order of this is also 2 into 2, and we find here A11 is same as B11, A12 is same as B12, A21 is same as B21, A22 is same as B22. So they are equal matrices. It means we can say A is equal to B. Since order of A is equal to order of B is equal to 2 into 2, and every Aij is equal to Bij. Based on the equal matrices, sometimes we have different type of problems to find the unknown elements. What type of problems are coming? Let's see that. The example is find x and y if these two matrices are equal. To find the solution of such problem, we have to use the concept of equal matrices. What we write here? We have been given the matrices equal. Since matrix x plus y 2, 1, x minus y is equal to 5, 2, 1, 1, we find here these are 2 and 1, they are equal. It means this first element should be equal to this. So this gives us the value x plus y should be equal to 5. This becomes the first equation. This element is to be equal to this. It means x minus y is equal to 1. This is the second equation. And now we have to find the solution of these equations. We can just add them. Adding 1 and 2, we get 2x is equal to 6. It means x is equal to 3. Substituting this value of x in 1, we get 3 plus y equal to 5. It means y is equal to 5 minus 3 equal to 2. So we have got the values of x and y. X is 3, y is 2. This is the answer. In the next video, we will learn about the operations in matrices. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.